For more information, please visit SGMAK Associates website.
Hi, here is a short presentation on use of normal distribution, the most used distribution in statistics, using Excel statistical function. Most of us use Excel to solve different kind of problems, and it has a good collection of statistical function, and that can help you solve basic problems in probability and statistics. So focus is on normal distribution. How do you solve normal distribution related problem using Excel? So starting with Excel provides 4 functions, statistical functions related to normal distribution: norm.distribution, norm.inverse, norm.s.distribution, and norm.s.inverse. A stands for standard. So norm.distribution and norm inverse for an arbitrary normal distribution. So let's look at the first one. Norm distribution 15, 10, 3, 1. So there are 4 arguments. The first one is the value of the random variable, 15. The second field is the mean of the normal distribution, 10. The third field is standard deviation. And the fourth field can take either 0 or 1. If you put 1, then the function behaves like a cumulative distribution function. It returns the value 0.952, and the meaning of it, probability, the random variable that follows normal 10 with mean 10 and standard deviation 3, probability that it takes value less equal 15, that probability is 0.952. So norm distribution can be used extensively to find probability of an event. Norm inverse 0.952, 10, 3. Norm inverse function takes the value of a probability and returns the corresponding value of the random variable. See, I mean, if you connect from the first line with the second one, you can see norm inverse 0.952, 10, 3 returns a value 15 as expected. So here I am input is the probability value 0.952 from a distribution mean 3 and standard deviation, mean 10, standard deviation 3, and the value of the random variable corresponding to that probability is 0.952. So it takes in a value for probability and returns the value of the random variable. Now norm.s.inverse and norm.s.distribution. A stands for standard normal distribution. Standard normal distribution is a random variable that follows normal distribution with a mean 0 and standard deviation of 1. So norm S inverse 0.95 is 1.645, implies that probability Z typically denotes standard normal variable. Z less equal 1.645 is 0.95. Norm.S.distribution 3.1. Now S is standard normal. So in this case, compared to the norm distribution, 2 fields are implied, mean 0 and standard deviation 1. So norm.s.distribution 3.1, the number is 0.99865, implies that the probability Z is less equal 3 is 0.99865. Now if you flip the last field from 1 to 0, then that number comes out to be 0.0044, and we'll talk about it in the next slide. It does not represent probability measure. Okay, if the last field is 1, behaves like a cumulative distribution function, returns a probability. But if you flip it to 0, then it doesn't represent a probability measure. So let's look at the following results just from the Excel lookup. function. Norm.s.distribution 0, comma 0, that means last field is 0. That number is 0.3989. Norm.distribution 10, comma 10, comma 1 and 0 is 0.3989. Norm.distribution 5, comma 5, comma 1, 0 is 0.3989. So the 0 in the last field does not return the probability measure. As you can see, all numbers are identical. The reason is they're all centered at mean of the distribution, and all distribution presented here have a standard deviation of 1. And 0.3989 is the height of the ordinate value of the density function, probability density function of a normal distribution at the mean value with a standard deviation of 1. So it's the ordinate, it is the value of the y, the ordinate of the PDF at that value of x. And we are looking at a value of x as the mean of the distribution, and all the three numbers that I've listed here, all three distribution, they have a standard deviation of 1. Okay, let's look at the next slide. We can solve any problem related to the use of normal distribution to estimate the probability of an event. Most of the probability problems are you're finding the probability of an event. So if you're dealing with a normal distribution, you want to find the probability of an event, those four statistical functions, you can use it very easily. The majority of the problems requires estimation of the probability of an event of the form that x lies between a and b, or probability x is less equal to value a, or x less greater equal to value b. There are problems where you use information related to probability of an event to estimate the value of the random variable. We just talked about that. So let's go through some examples. Problem statement. The breaking strength of a synthetic fabric is denoted by x and is distributed as normal with a mean of 750 units and standard deviation of 10 units. The purchaser of the fabric requires the fabric to have a strength of at least 775 units. So it's a quality related problem. Process is now giving you output centered at 750, standard deviation of 10. Any value less than 775 is a defective item. So what is the quality offered by the process? So we need to estimate what's the probability x is greater or equal 775, where the x follows the normal distribution with the mean 750 and standard deviation 10. So use the normal distribution and the value comes out to be 0.007. Greater than probability, you can always take the complement and the convert into a less than type of problem, and then you can use the normal distribution to find the probability of x less equal a. So in this case, the quality is 0.007. So you're generating very few good parts. So let's move. Purpose is how to look up the statistical function. So current quality offered by the process is very poor, and the process mean must be moved to the right to improve quality. Well, that's a separate issue here. Basically, you got to have center it at a higher mean, move it from 750 to a higher value to generate better quality. Let's look at another problem statement. A random variable x is distributed as normal with a mean 40 and standard deviation 4. Now determine the value of the random variable, an arbitrary value k, such that the probability x greater than k, greater equal, is 0.025. So whenever you have a greater than probability, you convert into a 1 minus the less than probability. So we are looking for a value of k such that the probability x less equal k is 0.975. Now here you have the probability. You want to find the value of the random variable. So you use the normal inverse. We got the probability value 0.975, and mean is 40 and standard deviation 4, and the value comes out to 47.84. Again, the purpose is how to look up appropriate table to solve a specific problem. So here's the general comment. If a random variable x follows normal distribution with a mean of mu and standard deviation sigma, and you want to find the probability of an event that x lies between a and b, so if we find it as what's the probability, cumulative probability up to b, and subtract the cumulative probability up to a by using the corresponding norm distribution function with appropriate parameters. Probability x less equal a is norm distribution a, mu, sigma, and 1. Whenever you have a greater than type of probability, x greater equal a equals 1 minus probability x less equal a, and so that equals 1 minus norm distribution a, mu, sigma, and 1. Be careful about the very last field 1 when you are finding out the cumulative probability. Most of the time it will be 1. Norm inverse k mu sigma returns the value of the random variable such that probability x random variable takes that value equals k. So here you're taking the probability and converting the corresponding value of the random variable. So those are the general equations that you can use. The standard normal distribution has mean 0 and standard deviation of 1. So remember, it's represented by z, and you can always take an arbitrary normal distribution with a mean mu and standard deviation sigma and transform into a standard normal by using the equation z equals x minus mu divided by sigma. We always transform an arbitrary normally distributed random variable into a standard normal variable to solve a problem by using the z lookup table. Okay, if you pick up any book on statistics, it has a standard normal table at the back of the book. So if you use that table, then you got to convert an arbitrary normal distribution into a standard normal distribution by using the transformation just listed here, z equal x minus mu over sigma. Then you look up the value from the z table and convert it back to x. The z table returns a value between -4 and +4. Moving on, a problem dealing with the standard normal distribution. I mean, you can just use normal distribution to solve any normal distribution problem, because a normal dot distribution takes parameter value of the random variable, takes mean mu, takes standard deviation sigma, and then depending on 1 or 0. So if you don't have to pay separate attention to standard normal distribution when you're looking at an Excel statistical function, because all that you do, standard normal distribution has a mean 0 and standard deviation of 1. Okay, so you may not have to use norm dot s dot distribution. Norm dot distribution can do the job. Okay, so these 4 functions, dot distribution returns the cumulative probability, and dot inverse takes the value of probability and returns the corresponding value of the normal distribution. Okay, so hope this short presentation is useful. Okay, thank you. Bye.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.